Good morning, everybody. My name is Jim-Flanagan. This is Norm Johansson, and we are software developers at AWS's Developer Tools team. Before we get started this morning, a couple of things. We're going to be showing some code on the screen, so now's a good opportunity to take us. There's plenty of seats up front if you want to see in good detail. The other thing is, please fill out the feedback. Give us a review of how we did. That's how we tune the content for next year. When filling out the evaluations, please take into account that last night's show is a hard act to follow. So what we're going to be talking about today is building .NET applications on top of Amazon Web Services. Norm and I are going to present from the point of view of a small development shop, just the two of us. It's like a startup or a side project. And we are building a social photo sharing application. And we think it's really cool. We want to run it in the cloud. But we want to focus more on what makes our application cool and interesting, rather than more on our application and less about creating and managing cloud resources. So we're going to be using Elastic Beanstalk to make our life easier. And we're going to be using DynamoDB and Amazon S3. The other thing we want to do is we want to develop, in addition to the web version of our application, a Windows phone or a Windows Store version of the application. So we're going to show how we can sort of reuse our work in that process. Now, side project Norm and Jim are going to be using some of the tools that day job Norm and Jim, along with our colleagues at AWS, make. We're going to be coding in C#, so we're going to code against the AWS SDK for .NET. We're going to be using Visual Studio Toolkit for debugging and managing and inspecting our cloud resources. We can use the PowerShell tools to manage our resources and do simple scripting tasks. And like I mentioned, we're going to be using Elastic Beanstalk and its customization features to deploy our application. A few words about these tools. Since last reInvent, you've asked us for the ability to code against WinPhone and Windows Store applications. So we recently, just a week ago, released the version 2 of the AWS SDK for .NET, which supports those platforms. The AWS Toolkit for Visual Studio now supports Visual Studio 2013. And you've asked us for the ability to customize your Beanstalk instances and deploy them more securely, and for single instance environments rather than load balance environments. So we've added that to the Elastic Beanstalk container. So now Norm is going to show us, both give an overview of what our application looks like, and we're going to dive into how we implemented parts of the application.
Okay, thanks, Jim. So this is our application we're building. It's our photo sharing app. We call it Cloud Shots. In this app, we can see the pictures of all our friends as well as ours. This happens to be a picture of my daughter, who really loves apples, so do not try and take apples from her. In this application, we can add comments to our pictures. We can also upload other images as well. So Cloud Shots uses DynamoDB and Amazon S3. We're learning our AV skills on the fly here. So Cloud Shots is going to put the images in S3, and we use DynamoDB to put the actual image data. And we chose DynamoDB for a couple reasons. As Jim mentioned, we're just a two-dev shop, and we just really want to play with the photos and do what we want to make things magical in that. We don't want to deal with infrastructure things. So DynamoDB, we don't have to think about setting up our database server, making sure it's being properly replicated in case it goes down. We want something fully managed, and that's what DynamoDB gives us. The second reason is, again, falls back to that we're just a two-dev shop, and we want easy scalability. We don't want to think about what happens when we grow beyond the demand of our current database server. How do we replace that? What do we do about query optimizations and things that we want? Easy scalability. In DynamoDB, we can basically go in, we can set what we think the scalability is now, and then once our application becomes that next big hot application, we can just adjust the knob to what the new demand is for our application. This is, oh. So how does DynamoDB work? We're mastering this skill, I promise. So DynamoDB works like most other databases where you store all your data in tables. Tables in DynamoDB do not have a fixed schema. And for each table, you're able to specify how much provision throughput you want DynamoDB to reserve for that table, which goes back to that knob I was talking earlier. So when we create our table, we need to define what is the key for the table. And DynamoDB keys are broken up into two parts. There's the hash key, which is what DynamoDB uses to provision your data across the DynamoDB system. So it's really important when you choose what is the attribute that is your hash key, that it's something that the data is going to be evenly distributed for best performance. The second part, which is optional, is called a range key, which is a really useful part in that it lets you be able to do queries on that attribute within the scope of your hash key. Sorry, I shouldn't laugh so loud. So when we create our DynamoDB tables, we need to specify what is the read and write capacity for this table. And this is that knob that I mentioned earlier, where we can set these values really low and then monitor the usage of it and adjust these read and write capacities as the demand grows. Now, the DynamoDB website has a lot of great information on exactly how read and write capacity break down, but it basically says how much read and write you can do per second. So to help you keep track of how your application is using DynamoDB, DynamoDB is going to push all of its metrics data to CloudWatch. And in CloudWatch, you can set up alarms, or you can go and view the graphs, and you can see how much you're using of your consumed capacity, and then make those appropriate adjustments. You can find out, hey, we've way over provisioned, we can lower those values down, or we've under provisioned and we need to increase the values. So what happens when our application starts trying to read or write beyond what we've provisioned? Well, the service is going to throw back throttling errors. And if you're using any one of the AWS SDKs, what they're going to do is they're going to catch those throttling errors and automatically retry them with an exponential backoff. And this will get you through if your application has a quick, sudden burst of activity, like you can see in this graph, where it then goes back to normal. But if you're constantly getting the throttling errors, that's when, again, you need to be able to go in and adjust those read and write capacities. And it's important to note, when you adjust those values, your table is still active. So there's no downtime while DynamoDB is re-provisioning the space for that table. So let's switch over to Visual Studio. And we'll show you how you can, through Visual Studio, create one of your DynamoDB tables. We're going to use the Explorer, the Visual Studio Explorer. If you haven't seen it or installed it, you can download it from our website. Once you do, under the Views menu, there'll be the AWS Explorer menu option. Under DynamoDB, we're going to see all the tables that we've created for our application. We've already got them, but let's go ahead and walk through the creation process to see what that's like. So we're going to recreate the image metadata table. And so for our image metadata table, what we're going to do is we're going to use the user ID as the hash key. So we're going to provision all of the images across based off of the user ID. And then we're going to optionally turn on the range key and set that to image ID. So the full key is going to be the combination of your user ID and the image ID. Now, a great feature that DynamoDB added this year is called local secondary indexes. In our application, we want to be able to get what are the latest images that users have put in. So we're going to put an index on the upload date field, so we can use that to get those latest images. They also just announced yesterday global secondary indexes, which we didn't use yet in our application, but there's some great use cases you can use with that as well. And down below, you can see there's that read and write capacity. We're going to leave these just at the default since we're still in the early development stages. And this also just keeps us in the free tier for DynamoDB. We could also turn on some basic CloudWatch alarms. Since our table's already created, we're just going to cancel that out for now, though. Back to the slides. So for the .NET SDK, we actually have 3 different APIs you can use to interact with DynamoDB. The first API we call is the low-level API, which works like all of the other clients in the .NET SDK, where there's a client object that represents the service. It's got a method for every one of these service operations. And each one of those takes in a request object, and it hands you back a response object. And this API works really great if you're trying to get as close to DynamoDB as possible, and you want to do things like exactly control how your data is being marshaled into DynamoDB. The second API we have is called the Document Model API. This works a lot like .NET dictionaries, where you create these document objects, which act a lot like dictionaries. You set your fields in there, including the hash key and range key. In our case, it's the user ID and image ID. And then using the table object, we can then put those documents in DynamoDB and get them back out. Now, this API works really well if the problem you're trying to solve, where each item in the table has a different set of attributes on it, like a heterogeneous set of data. And then the third API we have is called the Objects Persistence Model API. And this is the API we use in our application. What it does is it takes .NET annotated classes that the SDK uses to understand how do I save instances of these classes inside DynamoDB. Let's go back to Visual Studio and see some of the annotated classes we used for our application. So our application, we care about 3 different entities. We care about user profiles, image metadata, and comments. Let's look at the image metadata class. At the top, you can see an annotation that indicates what's the table I want this class to be stored in. It has a public default constructor, which is required so the SDK is able to create instances of this object. We then annotate what is the hash key and range key, the user ID and image ID. And since we have upload date as a local secondary index, that is annotated as well. Now, all other public properties will be persisted in DynamoDB by default. If there's fields that you don't want persistent in DynamoDB, you can mark them as ignored, which we've done here. And we've done that because the data X layer we've written around DynamoDB fills these fields in during the runtime. So let's look at one of our unit tests to see how you use these classes. Here in the setup method of our unit test, we create what's called the DynamoDB context object. And this is sort of the central object you use when working with the Objects Persistence Model API. It contains cached information about DynamoDB because it's doing describe tables to kind of understand what's the keys for that and indexes. So it's important to hold on to this object and not recreate it on a per request basis. Put it in a factory or something like that. And we look at our test, you can see we just sort of instantiate the instance of our image metadata. We set its fields. And then on the context object, we call save. To get it back out, we can call our load method, passing in our hash and range key. And then we could also call delete to remove the object as well. So S3 is the other service we use in our application. We use that to store the actual image files, which is a great use case for S3. S3 is great for just taking a chunk of data, in this case it's our images, and putting it in a bucket in S3. In S3, it's going to be called an object. And then it's going to be uniquely identified in that bucket with a key. It's a unique string that you created when you decided to put that object into S3. Another great feature of S3 is that all the objects you put in S3 are URL addressable, so that we can use those URLs to essentially put into our HTML pages so we can directly link those images in there. Let's go back to the toolkit, and we'll see how we use S3 in the toolkit. Under the S3 node, we can see these are the buckets we have for our account. And we can go ahead and double-click those, and that'll bring up the bucket browser. This shows you all the objects that you can have in this bucket. And from here, you can upload more, download those. We could also double-click on our image right now, and that's going to pop up in a browser. And this is, again, using that URL addressable feature. What the toolkit's doing under the covers is it's generating a pre-signed URL, which gives access to that object for a short amount of time using that specific URL. And then the toolkit just hands that URL to the browser and say, go open this up. And that's that same sort of technique we're going to use with our web application. So for our application, we developed a data access layer to encapsulate both working with DynamoDB and Amazon S3. Now, did you find the controller? We can drink the water here. Now, as Jim mentioned, we want to create a Windows Store app as well. Windows Store apps have the requirement that all operations that go over network must be called asynchronously. This is done so that your applications stay very user responsive. So when we used our SDK and our data access layer, we only used the asynchronous API from the SDK, so we could reuse the code in both platforms. So I just want to walk through a couple of our methods in our data access layer. The first is how we handle the uploads. So the first thing we need to do is we need to create that. We're going to upload to S3, and we need that unique S3 key. So we create that key by taking the word images and then slash putting in the user's username slash the file name. Once we have that key, we set up our request object. And that request object takes in the bucket we want to put the picture to, our unique key, and it also takes that stream, which contains the actual binary data of the image. We can also add a progress callback listener, which we're going to show off when we get to our Windows Store application. And then using the S3 client, we'll just put that into S3. And then once that's complete, we're going to save the metadata in DynamoDB, very similar to how you saw us doing in our unit test earlier. So given that sort of overview of how we're using those services and stuff, Jim's going to walk us through now how we're going to take our application and deploy it to the cloud.
So we mentioned that we want to get our application into the cloud easily and not have to think too much about the resources that are being created. So Elastic Beanstalk is a natural choice for this. It's going to create all of the resources that we need on our behalf. But these resources, the instances and load balancers and so forth, aren't hidden behind the Beanstalk abstraction. You retain full control of all of these resources. And it'll also allow us, as we're developing in a tight iteration loop, to deploy our application directly from Visual Studio. Now, as we've been developing our application, we've been giving our application the permissions it needs by putting AWS credentials in the web config file, which is fine for development. But we don't want to deploy those credentials to Elastic Beanstalk for a couple of reasons. Norm and I want to have a best practice of rotating our credentials every once in a while on a periodic basis. So every time we rotated our credentials, if they were on our Beanstalk instances, we would have to update our application. We don't want to do that. Also, we want to sort of limit the blast radius and not have to worry about where our credentials are. So the way we can do that is to use AWS Identity and Access Management to create a role. And a role simply describes a set of resources and what actions can be taken upon them. So in this simple example, we have an S3 bucket. That's the bucket for our application. And we want to be able to call getObject and putObject on it. For our DynamoDB image metadata table, we want to be able to call getItem and putItem. So once we've defined a role, we can tell Elastic Beanstalk to use that role so when it creates our EC2 instances, instead of looking in the web config for our credentials, the AWS SDK will see that an instance profile has been created for our instance. It will use that instance role to create temporary credentials, which are scoped to just the permissions that we gave it. And so our application can get to the resources it needs without having to ship credentials out there. So now that we have our role defined and our application put together, how do we get it into Elastic Beanstalk? To do that, we go back to Visual Studio and right-click on the web application project and select Publish to AWS. And this brings up the deployment wizard. Now, there are multiple ways to deploy an application to Elastic Beanstalk or to the AWS cloud, and we're going to focus on Elastic Beanstalk. And so on the next pane, we'll select a name for our application. By default, it's just our web application name. And then we can create an environment. Now, you can have multiple environments for an application. You can have a test environment, a dev environment, production, and staging, as many environments as you like. And you can select here what kind of environment you want this to be. Since this is our development environment, we just need a single instance. We don't need to scale up or anything. On the next slide, you can see we can select the instance size. So we just need a micro instance for our purposes today. And here's where you select the IAM role that we created earlier that will give our instances the permissions it needs to use those cloud resources. So we're going to skip the rest of this dialog, which has some advanced configuration, and go to the review screen. And this shows us all of the options that we chose. We can deploy our application right from here. But one of the things I want to point out is as Norm and I get more sophisticated, we want to build a continuous integration system and build system and deploy system. And we don't want to have to deploy our application from Visual Studio all the time. We can save these settings to a configuration file and use a standalone command line version of this deployment tool to deploy programmatically. So let's go ahead and click deploy. And you'll see this causes the web application to get built. And after the build phase, we upload the bits to Elastic Beanstalk. That'll take a couple of seconds.
This would be the time for us to get the long builds. Usually it's a fast build. But
yeah. Oh, yeah. Oh, because it's the first build of the morning, of course, after the party. Yes. Visual Studio is slow.
Well, I took my Surface to the party last night, and it's going slow.
That's why we called it Live at reInvent. So what would happen next is that we would see the events screen for Elastic Beanstalk. And that would show us the state of our environment and what resources were in the state of being created and what had been created, as well as any error messages or warnings that would come up. Now, we took the precaution of launching an environment before the talk. Let's go take a look at what that looks like when the deployment is done. So this is the environment screen. You can see the events. You can see that the environment is healthy. And up in the upper left-hand side is a link that you can just click on to go to our application. And there it is, running in the cloud. So Norm, when you loaded that application, I noticed something about the performance. The thumbnails on the left-hand side loaded pretty slowly. And I know this is, a hotel network or what have you. But what's going on there?
Well, I went to the party last night, so I didn't spend time coding on optimizing the images. So I'm just letting the browser resize the images on the fly there.
Okay, so those are the full-size images being scaled on the web page.
Yeah.
So we could probably do better than that. I have an idea. Why don't we create a thumbnail-sized image of the thumbnail-sized of that image right when the user uploads the image?
Yeah, I was worried. No problem with that. I was worried we might block the web process, and that might cause us some scalability issues.
Yep, it may impinge upon the perceived performance. What if we did it sort of like in a side process that was outside the request stream?
Yeah, and that's what we want. We want sort of a service to take care of that.
Okay, here's my idea. So the way our application currently works right now is when we upload an image, we put the image data in an S3 bucket, and we put the image metadata and other associated data in the DynamoDB table. Let's add a third step. Let's put a message on a queue that we create with a simple queue service. And that message is going to be the hash key and range key of our image in the image metadata table. Then we can create a worker process which is listening on that queue, and when it sees a message come in, it uses the key for our DynamoDB table to get the image metadata, and then it uses that to get the bucket and the key name for the full-size image. Then it crunches on the image to produce a thumbnail size and puts that back in S3 with a prefix of thumbnail. And then we need to tell the web application that there's a thumbnail available because it may not be there by the time the user reloads the page. So we update the image metadata table with a thumbnail key for that image. And then the last thing we need to do is to remove the message from the queue. So let's see what this looks like, what the image processor worker looks like. And we've organized this code as a class library, which will, when we deploy it, we'll wrap it as a Windows service. But during development, we'll just wrap it with a console application so we can check it out, test it, make sure that we're happy with the way that it works. So in the processor code, the first thing we need to do is set up a few of the clients with the SDK that we're going to use. We notice that we just call the constructor for the 3 clients without any arguments, without any credentials. That's going to cause the SDK to go looking for its credentials. It's going to look in the web config, not going to find them. It's going to determine that it's running on a EC2 instance. And then, oh, I'll use the instance profile to get the credentials. And we read a couple of configuration things that will allow us to create an instance of our data access controller, which is the same data access controller that's used by the web application. And then we enter a listener loop, which will break when we get some kind of cancellation token. And we listen on receive message from the queue. When we see that there's a message in the queue, we pull the message off, and we call process message. And then when process message returns, we call delete message. So let's see what's going on inside the process message method. So the first thing process message needs to do is get the hash and range key out of that message. And we just basically comma separated them, so we just parse those out. Get the user ID and the image ID. And then we create an instance of our image metadata using the user ID and image ID. So this tells us everything we need to know about the image and where to get it. We use that data to get the image out of S3. And so that gives us a stream of our image data, which we can plug into our resize method, which gives us another stream, which is the smaller image. We put that stream into an S3 put request. And so we just stream that back into S3. So how do we go about updating the image metadata table after this is all done? So to do that, all we have to do is add a thumbnail key to our image metadata object, and then call save on the context on the controller. So now that let's go ahead and see that in action. So we're going to use our console version of this app, fire it up, and see if it actually does what we think it does. So there it is. It's listening on the queue. But how do we without having our application running and putting messages in there, how do we test it? I have an idea, Norm. Why don't you go to the image metadata table and pick an image that we want to test.
All right. So here's our DynamoDB browser. We're just going to take this bottom one here. We need to get, I'm going to just whip over to our favorite editing tool, Notepad. Whoa, I don't know what that was. There we go. And we need our image ID, user ID, comma separated. Why are you doing that? It would not be a demo if things didn't happen on the fly like that. All right. For some reason, I've lost the ability to use shortcuts. Anyways, this is what we want to essentially put into our queue. So let's open up our queue in the toolkit. We can go ahead and send a message. And then back in the console, we can see it received the message, it's generated, and it creates that image. If we go back to the image metadata table and we rescan, you can see there's that new value.
Nice. So why don't you cut and paste the rest of those and put messages in there?
Well, you saw my skill in that. It does seem like a good idea.
No, we wrote a unit test, which is going to scan that table, create messages for each of the rows in that table, and put a message on the queue. And then we'll fire the console application back up and see, we'll give it a stress test with all of the data that we've accumulated so far.
So if we go back to our queue and we refresh, we can see here's all our messages sitting there waiting to be processed. We can double click and see them in more detail. Let's start that console back up and see those things get cranked out. receiving all those messages and generating. It's working fast.
Nice. So that seems to work. Let's go back and see if it populated the image metadata table for us.
All right.
And there are all our thumbnail keys. So this is a instance of how you can use the Visual Studio Toolkit to test out parts of your overall application without having to build a whole integration around it. So you can sort of put messages in queues, inspect your buckets, and make sure that your application is doing what you think it's supposed to be doing before integrating it all together. So now that we have our image processor working, we need to update the web application to make to have it put those messages in the queue. And to do that, we're going to add a little bit of code to our upload image method at the very end there. Why don't you put some code in there to update that queue?
Get my coding hands working. Let's see what we can do. My coding hands have decided.
The keyboard is no longer.
I think. Let's get that. Sorry about that, everybody. Apparently, I have to code everything on one line without any spaces. Anybody think I can do it?
This isn't Perl.
No, we're not doing that. All right. One second for technical difficulties here.
What if you restart Visual Studio?
So, okay, let's restart Visual Studio and see what happens.
This isn't actually a live demo. We actually recorded us doing this, and we're playing it back for you.
We thought it'd make it more interesting for you to see us fumble around.
Nice.
All right, we have the enter key again. We're good. Okay.
Hey, you remember the code you're going to write?
Yeah, I forgot it already. So we need to use our SQS client. And we want to send a message. Again, we're using all the async methods. We need to have two things. We need to have the queue URL. You are most likely going to have this coming through some sort of config file, something more fancy than we're going to do right now. But since we're just being quick in the demo, we're just going to take this from the toolkit and drag that out here in the wrong spot, but we'll get it there. And then we need our message body. And again, our message is with the comma. Meta, it's going to be user ID. And image ID. And I'm going to use the right variable. And building. OK, everything looks good.
So now all we need to do to redeploy our web application is to click on the project again. But where are we going to run our image worker, Norm?
Well, we're just in dev, so we don't really want to have a whole other instance just for this small process.
Why don't we pop it on the same instance that our web application is running on for now?
Yeah, that'll keep things good and simple for us.
OK. Well, our worker service is not part of our web application, so it wouldn't naturally get deployed to Beanstalk when we deploy our web application. But Beanstalk has the ability to allow you to layer configuration and customization on top of your EC2 instances. We're going to use this mechanism to download and install our service and make it run on all of the instances. Well, we only have a single instance, but it would run on all of the instances that's running your application. To do that, we need to create a folder in our web application called .eb extensions. And inside the .eb extensions folder, you can have one or more files with a .config extension. And these are going to be YAML formatted files. This is the format that's used across all of Elastic Beanstalk. This allows us to do things like create files, download files, install MSIs, anything we need to do in addition, to our application running. So for our example, the first key we have here is the files key. We're going to create a 2-line configuration file. You can create files by downloading content from a web accessible location such as S3. We're just going to inline it since it's just a 2-line file. The next key is sources, which allows us to download a zip file and unzip it at the specified location. Here I've created a pre-signed URL for all of the bits for our service worker. And then you can run one or more commands inside this file. We're going to use the install util to install our service bits as a service. And you can specify tuning things like we're going to have that command run in our image resizer service directory. The next key is services, which causes Elastic Beanstalk to ensure that our service is running. And then the commands part of that key says, don't try to run the service until this command has run, because that wouldn't make any sense. It wouldn't be installed. And then the last section we're using here is option settings. You can set all sorts of settings to change the behavior of how Elastic Beanstalk works here. You can also add key value pairs to your web config through this mechanism. And that's what we're doing here. We're adding an S3 bucket and the queue name for our queue. So now that we have our EB extensions configuration file specified, all we need to do is right-click on the web application and select Republish Environment. And that brings up the republish. It would bring up the republish dialog if we had published our application. But you don't have to fill out any of the options. It uses all of the configuration that you had used before, so it's just a one-click operation. So now that our application is running in the cloud, Norm's going to show us how to build a Windows Store version of that application.
Thanks, Jim.
Whoops.
I think we're good.
Yeah.
So with .NET version 2 of the SDK, which we released just Friday, it added support for Windows Store and Windows Phone 8 applications. Again, in these 8 versions of the SDK, it only supports the asynchronous version for the APIs. For Windows Phone 8, we support 11 of the services, focusing on the services you mostly want to call from a phone, like S3 or DynamoDB or SQS. And then the Windows Store version of the SDK does support all of the services like the regular version of the SDK. To support all these different platforms of basically regular Windows, Windows Phone, Windows Store, we actually generate different assemblies for each of these different platforms. If you were to install our SDK from our website, your install folder would look like this, where there's a .NET 4.5 and 3.5 folder, which contains the regular version of the .NET SDK that you use for your regular C# applications or ASP.NET applications. The difference between these two is .NET 4.5 is using the task-based asynchronous pattern, and it's also based around the new HTTP client added in .NET 4.5. The 3.5 version is still using the begin-to-end asynchronous pattern. Then there's also folders that contain the Windows Store and the Windows Phone version. We also still put down a copy of the version 1 SDK for applications that aren't ready to move to version 2 yet. So when we coded our data access layer, we did want to reuse all that same code. But we did create a separate Visual Studio project that links in the same C# files, but it has a couple differences. The first difference is it targets the Windows Store runtime, and it's also going to reference the AWS or the Windows Store version of the AWS SDK. So credentials management is something that you need to take special consideration when making applications for these mobile platforms. You don't want to embed your credentials where someone might hack your file and take those out. You'd also never be able to rotate your credentials as well, which is a really good practice to do periodically. On our website, we've documented a couple strategies you can use to get your credentials securely to your application. The first is called Web Identity Federation, which uses an OAuth provider like Facebook to handle the logon. It will generate an OAuth token, and then using Amazon Security Token Service, generate some short-lived security credentials with a reduced permission set. Another approach you can use is called Token Vending Machine. And this is something you would use if you wanted to handle your own custom authentication or maybe handle anonymous logon. In our application, we used Web Identity Federation. So to take a look, let's take a look at the code in our Windows Store application to see how we created our credentials. So here in our class here, the first bit of code is going to call some wrapper code I wrote specific to our application, wrapping around Facebook's API. We're not going to go into depth on that, but basically what it's going to do is it's going to return back this identity object, which contains our OAuth token, our user ID, and our username. Now, given that, we're going to call this AWS logon class that I wrote, which again is a more wrapper code I wrote for this application. And what it does is it's going to translate that identity object into some AWS credentials object that our SDK can use. So let's go ahead and open that class up. So what this is going to do is it's going to call security token services assume role with web identity, which is a very unique method in the SDK in that it takes no credentials to call this method. So when we create the security token service client, we actually pass in the native anonymous AWS credentials object. Once we have our client object, we set up our request. In our request, we need to indicate that Facebook is our provider. We're going to give it our OAuth token. We're going to name the session with the session ID or the user ID we got back from Facebook. And then we have to tell it what is the role we want to assume. To take a look at this role, we're going to log onto the web console because we don't yet have support in the SDK for trusted, in the Visual Studio Toolkit for trusted relationships. So once we're in the console, let's go to the IAM section. In IAM, we're going to go to roles. And you can see here's the role we set up for our application. Permissions is going to use the same permissions that our web application. So I'm not going to really go into that. What I want to show you is the Trusted Relationships tab. In this section, the trusted entity is identifying what is the provider that we're using. And this is what's mapping to what I'm passing in the code. You see Facebook here and Facebook there. In the trusted entity, or the condition, what that is saying is that the OAuth token that I'm passing in that assume role has to be a valid OAuth token for that Facebook application ID, which Jim and I created earlier when we went into Facebook and created our application. So security token service will find that it's a match, come back to our code, and give us back our access key or secret key and a token object. And from that, we can create a AWS credentials object. With that, we can then hand that off to our SDK and use our SDK as we have been using throughout today's talk. But again, it's going to be doing that with a reduced permission set, and we never had to embed any credentials in our application. So let's fire up our Windows Store app and see what it looks like. So we have to log on to Facebook right away so we can get that OAuth token that will pass to security token service to get our credentials.
And I'm keyboard challenged here.
For our demo, we're doing it on a Surface, so I got the little bitty keyboard just to challenge him with it.
Why don't you log in?
Okay. I think we're just going to restart just so we've had enough Murphy's issues today. So. You got to get in with the Facebooks, Jim. So here's our same application. It has the same functionality as our web apps, just being in a more Windows Store presentation. We can view images. We can add comments as well. What are you saying about my daughter?
That's a big apple. Relatively.
She was very proud of that apple. We can also upload images as well. Let's upload a picture right now. And we're going to take a picture to glorify our last day here at reInvent.
No camera. Where's the camera? There we go. Everybody smile.
Big waves or anything. Air cheers.
Okay.
So we can add a caption on there. And notice at the bottom there's that little gray bar. That's that progress callback, or progress I was mentioning when we went through the data access layer. When Jen uploads that, it'll fly right by. Or I guess we're on a hotel Wi-Fi, so maybe not so fly by. But it makes for a more dramatic demo to watch it in slow motion. So the last little bit of code I want to show then is how we hooked up that progress callback. So let's go to our upload method in our Windows Store application. Down the bottom.
There it is.
So here, upload method is calling our data access layer. It's passing the additional operation, which is the callback method. And the DAO is passing that in the SDK. And what the SDK is going to do, as it writes chunks of data to S3, it's going to call back on that, and with an event argument that tells us how much data has been written and how much will be written total. So in the callback, all we have to do is update our progress bar with those values from the event argument. So that's what we wanted to show you. Hopefully, you've learned a lot of great stuff. We've inspired you to come try our tools and SDK. You can download our full suite of tools and SDK from our website. The SDK is also available through NuGet, and it is an open source project. We host it on GitHub. If you want to add any contributions, have any great ideas that should be added to it, go there, let us know. Once you try it out, let us know what you think. You can get a hold of us through our forums or through GitHub, and we do also participate through Stack Overflow. And I want to also mention that we'd like it if you would follow us. We have a Twitter handle we just started 2 weeks ago, right? Mm-hmm. And we also run a blog for .NET and Windows development where we talk a lot of these sort of issues that we're talking about today. And just one more last plea of please fill in the feedback forms to let us know what you think of our talk so we can improve our talks for next time.